We'll see these points. These are few of the technologies that will few of the terms that we'll use while understanding the performance evaluation of a computer. So this we'll start with clock. Then what is the clock rate? Okay, what is clock frequency? What is clock cycle time? Okay, we'll use a very simple graph to understand these terminologies related to clock. Okay, then we'll see that the entire concept of this clock, when we are trying to understand, we are trying to use, or we are using a timing signal based on which we'll say that this is my clock, or this is the rate of the clock, or this is my frequency. So frequency is again a term which will come here into picture. Okay, we all know that the unit is hertz. So what do we mean by that? My system is my processor is running at 300 gigahertz or 700 gigahertz. So what do we actually mean by that, and what correlation it has with the cycle time? Okay, so obviously time and frequency, when we talk about, so we'll see a indirectly proportional relation between them. Okay, so we'll see like how the frequency is more and the time required to execute particular instruction is less. Okay, so we'll see that. And can we say that a 700 gigahertz system is better than 300 gigahertz in each and every way? Can we generalize this term? We'll see this. Okay, so this particular thing, that system X is suppose need a time faster than system Y. So how to get or how to conclude this particular statement? Okay, so obviously performance is an indirect measurement, so it is calculated based on the following parameter. Okay, so the parameters here are the execution time. Obviously we saw like what time it is taking to execute a particular instruction. Okay, the throughput and the speed up. Okay, we'll discuss all the 3 points together from the PDF. Okay, so let's start here. So when we talk about the measuring performance in a computer, when can we say that one computer or architecture or design is better than the other? Okay, so when we talk about the desktop PC or your laptop, what you're using right now, okay, so the execution time of the program is the main factor which we are talking about, like how much time it is taking to actually execute that particular program. When we talk about a server, you can take if you want to think about that particular server, so you can always use the website website for booking any tickets. Okay, any rail IRCTC you can think about, or you can talk about Indigo. Okay, so when we are talking about the transactions per unit time, because when you will send a request to IRCTC or Indigo, okay, you are not the only one who is sending a request, and you are not the only person who will get a response from that particular server. There are like millions of users and users who are trying to book a ticket. Okay, so that server has to take the data, it has to process based on the dates and the schedule that you have you wanted to book a ticket for, and accordingly it will show you like these number of seats are available, or it is not available based on the that time constraint, and it will send you the response. And when you'll click that okay, I want to book this as per the requirement, then it will confirm it from that part. Okay, so here the transactions that it will do, the server will do in a unit time, is nothing but the throughput, this term throughput. Okay, so you have to just remember transactions per unit time. So when can we say that X is n times faster than Y? So execution time of Y upon execution time of X is suppose this is a factor which is equal to n. Okay, so looking into this particular formula, you can see here throughput of X upon throughput of Y is equals to n. So here the execution time of y was in the numerator, but here the throughput is in denominator. So we'll see like how this particular thing we obtained, okay, with respect to this particular formula. Okay, so you can like directly, if you want to see from this slide only, so you can see here when we talk about throughput, we are talking about per unit time. Okay, per unit time. So that means my time is in the denominator part. Okay, so when I talk about execution time, okay, and when I talk about the throughput, so obviously my time will be in the denominator part. So that's why if execution time is y here, the throughput is y is here in numerator, here throughput is in y. So we'll take this, we'll take an example and try to understand it in a better way. Okay, so before going to this, I'll just share one more slide. Okay, so let's try to understand this with a particular simple timing diagram. Okay, so obviously here we are talking about students. Till now, any doubt, any problem in audio, because I have connected the headphone with the
No,
CPU.
sir.
Okay,
It's
okay,
clear.
fine. So let's see this particular part, like how based on our basic knowledge of digital electronics, how we can correlate this particular performance equation. Okay, so this is a graph, a very common graph that we used in digital electronics. Okay, so you can see here I have only two values, either 0 or 1. I am talking about a binary system here. We know that my computer can only understand in terms of 0 and 1. So when we are trying to execute an instruction, so we are doing one instruction at a time. Okay, we'll talk about multiprocessing also, but let's talk like from a very basic thing. So the processor circuit is controlled by a timing signal known as a clock. Okay, so we are saying that this particular timing signal, when we are talking about this, so this is nothing but a clock. So first of all, we'll see that what is one clock period. Okay, so you have, before this also you have a knowledge, like for example this is a graph. So this was a sinusoidal graph that we all started with, okay, in first year. So when we talked about one complete cycle, okay, we started like my graph started from 0, reached a peak value, came to 0, reached a negative peak value, again came to 0, and after that again it started from here. So the point at which the graph is repeating itself, okay, again, so that is nothing but a complete cycle. So this is one cycle. Similarly, when we talk about this timing signal, okay, timing signal, which is also known as clock, okay, so we'll see that portion. And when we talk about the period, one clock period, so here we are talking about from where one positive edge, so this is my positive edge and this is my negative edge. Okay, so you can see here it started from here at this point, and again you can see that after this again this thing will repeat itself. You can see this is repetition, nothing but repetition of this particular part after this. Okay, so you can also say that from here it started, for example, okay, and again from here that graph started, okay, repeating itself. So you can either take a rising edge or you can also take a falling edge. Okay, so that doesn't matter from where you are trying to calculate the period. You have to only think like it should repeat itself. The graph should repeat itself after that. So that corresponds to one cycle. Okay, so one cycle or one clock period is defined as rising edge or the falling edge, rising to rising or falling to falling edge transition as shown in this particular diagram. Is this point clear, students? What is a signal? What is a clock we are talking about, and what exactly is one clock period? Any doubt in this slide? Anyone? We can discuss. Okay.